Alright, go ahead and pause the video and give this one a shot. Determine the number of protons, neutrons, and electrons in the following isotopes that are used in medical diagnoses. Alright, so atomic number 9, mass number 18, charge of -1. If we look this up on the periodic table, we see that the element with an atomic number of 9 is fluorine. So here's what the isotope symbol would look like for this particular isotope. So when we know what the atomic number is, then we know what the number of protons is. It's the same. The number of neutrons we can find by taking the mass number and subtracting the atomic number. So in this case, 18 minus 9 equals 9 neutrons. And so this has a charge of -1. So remember, when an atom is neutral, the protons and the electrons are equal. So if this fluorine atom were neutral, it would have 9 protons and 9 electrons. But it's not neutral, it has a charge of -1. And remember that electrons are negative, protons are positive. So if this has a charge of -1, that means it has 1 electron extra, 1 more electron than protons. Alright, let's look at the next one. Atomic number 43, mass number 99, charge of 7 plus. So the element with an atomic number 43 is technetium right here, Tc. Alright, so the atomic number is 43, so it has 43 protons. It has 99 minus 43 neutrons, so that's 56. And it has a charge of +7. So that means that if the protons are positive and the electrons are negative, this has 7 extra protons. So I can't change the number of protons, that's given by the atomic number, so that means I'll just decrease the number of electrons. So this must have 36 electrons, a difference of 7. 7 protons that are above the number of electrons to give us a positive charge. Alright, the atomic number 53, mass number 131, the element with an atomic number of 53 is iodine. And it has a charge of -1. So if it has an atomic number of 53, that means it has 53 protons. If it has a mass number of 131, a mass number of 131 minus 53 protons would give us 78 neutrons. And if this has a charge of -1, then it's just like the first one. It has 1 extra electron in protons. So 54 electrons, 53 protons. Alright, atomic number 81, mass number 201, and the element with the atomic number 81 is thallium, Tl. And a charge of +1. So if it has an atomic number of 81, that means that it has 81 protons. If it has a mass number of 201, then that means it must have 120 neutrons. And if it has a charge of +1, then that means that it has more protons than electrons, and it has one more proton than electrons. So 81 protons and 80 electrons. So we already named the elements in A, B, C, and D there. This is fluorine, technetium, iodine, and thallium. Alright, go ahead and pause the video here for a minute and give this one a shot. Okay, give the number of protons, electrons, and neutrons in neutral atoms of each of the following isotopes. Alright, let's do protons, neutrons, electrons. Alright, so an isotope of boron that has an atomic number of 5 has 5 protons. If it has a mass number of 10, then it has 10 minus 5 neutrons, so 5 neutrons. And if it's neutral, then it has 5 electrons. This atom of mercury has an atomic number of 80, so it has 80 protons. It has 119 neutrons. And if it's neutral, then the number of electrons and the number of protons is equal. So 80 protons, 80 electrons. Right, this atom of copper has an atomic number of 29, so it has 29 protons. It has 63 minus 29, 34 neutrons, and if it's neutral, protons and electrons are equal, 29. This atom of carbon has atomic number 6, 13 minus 6 neutrons, and if it's neutral, electrons and protons are equal. 77, 34, selenium has 34 protons. 77 minus 34 neutrons. And again, neutral atoms have the same number of protons and electrons.